Okay, guys, so today we're going to be still factoring, but this time we are going to learn tricks to factoring, and sometimes the trick works and sometimes it doesn't. All right, so some of these we'll be able to factor, some of these we can't factor. Okay, so the first one is called the difference of two squares. All right, so it's whenever you have this term, which is a perfect squares, and it says difference, that's huge, so it has to be a subtraction sign between the two. And then this one is also a perfect square. All right, so whenever that happens, you can use this rule. You take the square root of the first one, you take the square root of the second guy. These two will look exactly the same, except once you'll have a plus, one you will have a minus, and I'll show you why in a second, okay? So both of them have to be perfect squares, and there has to be a minus sign between it. All right, and then I'll actually show you why it works. Okay, so on example 1, I know x squared is a perfect square. I know 16 is a perfect square. So remember what a perfect square is. A perfect square is when you have a number that you can multiply by itself to equal that number. So for example, x squared is a perfect square because x times itself is x squared. 16 is a perfect square because 4 times 4 is 16. So you see how the same thing times itself will give you this? The same thing times itself will give you this? That's what a perfect square is. Okay, so remember, like I said, it has to be the difference of, so there has to be a subtraction sign between them. So perfect square, the difference of perfect squares. Okay, so the rule is I'm going to take the square root of this guy. So the square root of x squared is x. I'm going to take the square root of this guy, which is 4. And I'm going to have the same thing in each set of my factors, except now I'm going to put one as a positive, one as a negative. And that's my answer. So I don't even have to do the whole tic-tac-toe thingy. I can just follow this little shortcut. All right, so now I want to explain y to you. So watch. I'm going to actually double distribute this out and show you how it comes out to x squared minus 16. So if I take x times x, that gives me x squared. If I have x times this negative 4, that gives me a negative 4x. 4 times x is a positive 4x. And 4 times negative 4 is a negative 16. So now what we do is combine our like terms. I have x's here and here. My x squareds drop. Notice these are opposites. A negative 4x, a positive 4x, those cancel. My negative 16 drops. So that's why you have to have 1 plus 1 minus, because you're going to want these terms to cancel out. All right, so my final answer on this one, factored, is x plus 4 times x minus 4. So remember, this little shortcut works where you don't have to do the whole tic-tac-toe thing. Is when this is a perfect square, this is a perfect square, it's the difference between them. Okay, so if I'm looking at example B, I know x squared is a perfect square because x times x is x squared, same thing times itself. 25 is a perfect square because 5 times 5 is 25. But this one will not work because it is not the difference. So the rule says the difference of two squares. So nope, that's not difference. Difference means subtraction. So I can't factor that one. Can't do it. Done. Okay, so on this one, I see that 4x squared is a perfect square because 2x times 2x would give me 4x squared. Same thing times itself. 25 is a perfect square because of 5 times 5. And it is the difference between the two, so I can use my trick. I'm going to take the square root of this first guy, which is 2x. I'm going to take the square root of 25, which is 5. Put the same thing in both of my factors. But remember, one has to be a plus, one has to be a minus, because we want our x's to cancel out here in the middle. See how there are no x's? So if I were to double distribute, I know my x's would cancel because they would be opposites. See that there's no x's here? It goes from x squareds just to the regular numbers. Okay, on this one, I know that x squared is a perfect square because x times x. But 10 is not a perfect square. There is no number I can multiply by itself that would equal 10, which means I can't factor this one. So if I can't do it, move on. I can't do it. I can't factor it. Okay, this one looks weird, but it's okay. I know 81 is a perfect square because of 9 times 9. I know 25x squared is a perfect square because 5x times 5x will give me 25x squared. And it's the difference between them. So I'm going to take the square root of 81, which is 9. I'm going to take the square root of 25x squared, which is 5x. I'm going to put that same exact thing in my other factor. And remember, we want our x's to disappear, so I'm going to have 1 plus, 1 minus. So when I would double distribute, I know my x's would be opposites. They would cancel out. Okay, this next one's kind of tricky, and the reason it's kind of tricky is because we see a plus sign right here, so immediately a lot of people think, it's not the difference, I can't do it. But remember, when you're adding two things together, the order does not matter. I can say 2 plus 3 or 3 plus 2. It doesn't change. So I'm going to flip-flop the order of these. So I'm going to have my x squared first, and then I'm going to have my negative 36. And so as you can see, it really is the difference. So let's see if these are both perfect squares. Well, I know x squared is because x times x. I know 36 is a perfect square because 6 times 6. And it's the difference between two perfect squares, so I'm going to use my rule. I know the square root of x squared is x. I know the square root of 36 is 6. So remember, I have to have 1 plus sign, 1 minus sign, because as you can see, there are no x's up here, which means when I double distribute, I have to have opposites, so they would cancel out. Okay, so like I said, guys, this rule is awesome. You don't have to tic-tac-toe. If you are able to catch this rule, if you are able to identify that we have two perfect squares and it's the difference between, you can just use this little trick. If not, your tic-tac-toe would always work. All right, so what I want you to do is pause the video, and I want you to try A through F on this next page by yourself, and then you can check with mine, okay? Okay, please make sure that you check yours with mine, that all of yours match mine. Okay, if not, find where you messed up and fix it. Okay, so now we're going to go on to same idea. Okay, so on example 2, okay, so now what we're going to do is we're going to kind of practice kind of what we did the other day. We're going to factor out the greatest common factor first, and then we're going to use tic-tac-toe. So the first thing I do is for my GCF. So remember, we can use our calculator to help us if we're not very good at it. So I need to find the greatest common factor between 6, 21, and 9. So I go type in my two smallest numbers, so 6 and 9. Oops. So menu 2, 5. 6, 9, which most of y'all should be able to do this in your head, is 3. Okay, but we always have to check, does 3 go into our third number, which was 21? Let's say we don't know, so I'm going to take 21 divided by 3. Do I get a whole number? Yes, I do. So I know 3 goes into all three of them. 3 is my greatest common factor. Okay, then we check our variables. I see x's, but I see that this group does not have an x, so they do not all have x in common. So my only greatest common factor is 3. So remember, I'm going to take my greatest common factor and then I put my parentheses. And now inside the parentheses, I'm going to put what I get when I divide each of those by that greatest common factor. 6 divided by 3 is 2. My x squared drops. Negative 21 divided by 3 is a negative 7. My x drops. And 9 divided by 3 is a positive 3. So I know this is the part now that I need to tic-tac-toe. Before I tic-tac-toe, I'm going to look at this guy. This tells me my signs are the same. So I know it's going to be either a plus plus or a minus minus. To tell which one it is, I look at my first sign. The first sign tells me they both have to be minus signs. Alright, so let's go ahead and tic-tac-toe. I'm going to go ahead and draw my 3 lines. Okay, I'm going to put my first and my last term side by side, so 2x squared and 3. My middle term, including the sign in the bottom box, so minus 7x. Alright, here I need to write my factors of 2x squared, so what can I multiply together to give me 2x squared? Well, that's a 2x and an x. And then I need to write my factors of 3, which is 1 times 3, and 3 times 1. Alright, so let's fill it in, my 2x and x. And now it's trial and error, so I'm going to try 1 and 3. I multiply across the top, 2x times 1 is 2x. I multiply across the bottom, x times 3 is 3x. There is no way I can use a 2 and a 3 to either add or subtract to give me 7, so that one does not work, which is why we use our eraser. Now we have to try our next option, which is 3, 1. I multiply across the top, 2x times 3 is 6x. I multiply across the bottom, x times 1 is 1x. Okay, this looks better. But remember, never get too excited until you check your signs. So we know that they both have to be minus signs, so go ahead and stick a minus on each one. A negative 6 combined with a negative 1 does add up to a negative 7, so I found the 1. I'm going to slide this negative over in front of 3, slide this negative over in front of 1, and then crisscross. So my first factor is 2x minus 1. My second factor is x minus 3. And I cannot stop yet. I have to remember to put my greatest common factor out front. My greatest common factor was that 3. Let's go ahead and skip B for now. Okay, on this one, let's find my greatest common factor. So I need to find the greatest common factor between 10, 22, and 24. So I'm going to go type in my two smallest numbers, so 10 and 22. So menu 2, 5, 10 comma 22. It tells me the greatest number that goes into both of those is 2. So I always have to check my third number. Does 2 go into 24? Yes, it does. I know that because 24 is an even number. All right, so 2 goes into all three of those. Then we look at our variables. I see x's, but this group does not have an x, so they don't have it in common. So I put my greatest common factor out front, and then in parentheses I'm going to put what I get when I divide each of these by my greatest common factor of 2. So 10 divided by 2 is 5. My x squared drops down. 22 divided by 2 is a positive 11. My x drops down. A negative 24 divided by 2 is a negative 12. All right, so I know this is the part that I'm going to have to tic-tac-toe. I look at this last sign. I see that it's a minus sign, which tells me my signs will be different. I'm going to need one plus and one minus. So I'm going to keep that in mind for later. So now let's go ahead and go tic-tac-toe. So I put my first and my last. I'm going to put 5x squared and 12. My middle term including the sign, so that plus 11x goes down here. All right, so now we have to find my factors of 5x squared. So what two things can I multiply together to give me this guy? Well, that's 5x and x. My factors of 12 are 1 and 12, 12 and 1, 2 and 6, 6 and 2, 3 and 4, 4 and 3. All right, so now I know guess and check might type me 1, 2, 3, 4, 5, 6 total guess and check options, okay? So remember, it doesn't make it any harder, it just makes it a little bit more tedious, okay? So I'm going to go ahead and put my 5x and my x. Let's go ahead and start with my 2 and my 6. I don't like these in my head, so let's play with 2 and 6. Multiply across, 5x times 2 is 10x. Multiply across the bottom, x times 6 is 6x. Well, there is no way either by adding or subtracting, a 10 and a 6 will give me an 11, so that's not it. So I got to try my next option. So now I'll try 6 and 2. I'll multiply across the top, 5x times 6 is 30x. I multiply across the bottom, x times 2 is 2x. There's no way either by adding or subtracting a 30 and a 2 will give me this 11, so that's not it either. Okay, maybe third time's the charm. Let's try 3 and 4. Multiply across the top, 5x times 3 is 15x. Across the bottom, x times 4 is 4x. A 15 and a 4 does give me 11, so I'm not going to get too excited yet. I have to try my signs. I know 1 is a plus, 1 is a minus. Well, I know I want to end up with a positive number, so I'm going to give my plus to my bigger guy. So let's check. Does a positive 15 add a negative 4 give me a positive 11? Yes, it does, so I found the 1. Slide your plus sign over in front of your 3. Slide your minus sign over in front of your 4, and then we can crisscross. So one of my factors is 5x minus 4. And my other factor is x plus 3. Remember, we cannot forget about our greatest common factor, so I need to put that 2 out front. All right, so I want you to go ahead and give these a try on your own, okay? After you try it, or pause your video while you try it, and then you can watch mine to make sure you did it correct. All right, get after it. Okay, so make sure you are checking yours with mine, that they match. Remember, guys, so on your final answer, like on A, if you have these flip-flop, that's fine as long as you have 2x plus 3 in one set of parentheses and x plus 3 in one set of parentheses, okay? Can't forget your greatest common factor out front. On B, same thing. If you have 7x plus 2 and x minus 6 in each set of parentheses, you're fine, even if you wrote this one first, oops, or you flip-flopped. So go ahead and make sure that you have all of those correct. You can pause it on this screen if you need to. Pause it on this screen, make sure you have all of those that match mine. If not, find your mistake and fix it. Alright, bye guys.